Good evening everyone. I hope I am audible to everyone. I am Reactive doing PhD under the supervision of Professor Sudeep Mishra at IIT Kharagpur in the Department of Computer Science and Engineering. Today we are here to discuss the topics of week 11 and further we will discuss the questions of same week. So first of all, we are going to discuss about the smart grid. So smart grid is conceptualized as a planned nationwide network that uses information technology to deliver electricity efficiently, reliably, and securely. Smart grids are also called electricity with brain, the energy internet, and the electronet. So according to the definition by NIST, smart grid is a modernized grid that enable bidirectional flow of energy and uses two-way communication and control capabilities that will lead to an array of new functionalities and applications. So here in this diagram you can see that with the help of smart grid, end users are getting electricity, and here we are using smart meters and also various types of sensor and actuator networks in order to transmit the electricity in a smart manner and in order to manage the electricity usage. Now what are the benefits of using smart grids? So the smart grids include more efficient transmission of electricity. It is quicker restoration of electricity after power disturbances in case of your smart grid. It also reduced operation and management cost for utilities and ultimately lower the power cost for consumers. It reduced peak demand, which will also help lower electricity rates. It increased the integration of large-scale renewable energy system. It provides better integration of customer-owner power generation system, including renewable energy systems. It helps in improving the security, and with the help of smart grid, both the consumer and the energy service providers get benefited. So here in this diagram you can see the conceptual model of smart grids, where this cloud shaped is your domains, that is various domains that are available in your smart grid, and dotted lines are the electrical flow, whereas this solid line of blue color are your secure communication flow. So basically electrical flow take place between your transmission, distribution, generation and customer. For example, the power is generated at this module and it is transmitted and distributed to the customers. Further, the communication take place between your the point where electricity is generated to the customers and the various units which are responsible for the distribution and transmission also. And apart from that, the communication also take place between the service providers, operations that are available, and the market. Now what are the properties of smart grid? So in case of your smart grid, consumer participation is there. So consumers are responsible for real-time monitoring of your consumption, that how much power or electricity you have used. Consumers are responsible for controlling the smart appliances and also for building the automation. Next property of smart grid is, in smart grid there is real-time pricing. So you will get to know about the price of the amount of electricity you have used in real time. The third property is distributed generation. So in case of your smart grid, the power is not generated in a centralized manner. However, it is generated on different nodes or different microgrids, and further the power is integrated. So in case of your smart grid, integration of renewable energy resources is there, and integration of various microgrids is present. Now next property is power system efficiency. So smart grid are responsible for monitoring the power. It also enable asset management and optimal utilization, and further it helps in the distribution of automation and protection. Next property is power quality. So in case of your smart grid, the power which you are getting, or the electricity which you are getting, is self-healing. So the network of electricity, if there is some point of failure, then it will get healed automatically. There is no need of human intervention there. Next one is frequency monitoring and control is there, load forecasting is there, and next one is anticipation of disturbances is also present in your smart grid. Now the components of smart grid. So smart grid, there are 6 main components of smart grid. These are your smart homes, renewable energy, consumer engagement, operation center, distribution intelligence, and plug-in electric vehicles. We will discuss about these components one by one now. So for smart homes, we have already discussed in our previous lectures that what is smart home. Here I will give you a brief introduction only. So smart home uses emerging smart grid technology to save energy. It seeks out the lowest rate and contribute to the smooth and efficient functioning of the smart grid, of the electric grid. Next point is the interactive relationship between the grid operator, utilities, and consumers helps in proper functioning of the smart grid technologies. Computerized control in smart homes helps to minimize the energy use at times when the power grid is under stress from high demand. So whenever there is a high demand at the power grid, so with the help of computerized control, you can minimize the use of electricity at your home. This helps in reducing the shutdown of your power, or also introducing the cost in the peak hours. Next component was your renewable energy. So according to the International Energy Agency, renewable energy is derived from natural processes that are replenishing constantly, and in its various forms it derives directly from sun or heat generated deep within the earth. Included in the definition is electricity and the heat generated from your solar, wind, ocean, hydropower, biomass, geothermal resources, and biofuels, and hydrogen derived from your renewable resources. It helps in reducing the environmental pollution. It makes the consumer capable of generating energy from renewable energy resources are less dependent on microgrid and main grid. In addition to that, they can also supply surplus amount of energy from renewable sources and can make profit out of it. Now consumer engagement. Consumer can, with the help of smart grid, consumer can save energy with proper scheduling of smart home appliances. They have to pay less for consuming energy in off-peak hours. After that, energy service providers give incentive based on the energy consumption of the consumer, and they can save money. So with the help of this incentive mechanism, these consumers are supposed to use less energy, and because they know they are going to get incentives, due to which they will make proper use of energy. Consumer involvement in the in following ways. So how consumers are involved in your smart grids? Now we will discuss that. The time of use, pricing, net metering, and financial incentives. Now operation centers. So firstly we will discuss about the drawbacks of a traditional operation center, and then we will discuss that how smart grid is responsible for operation centers. So the drawback of traditional operation centers are, traditional operation center tries to make sure the amount of generated energy is getting used. The grid is unstable if the grid voltage drops due to the excess energy generation. It has limited control capabilities. There is no means to detect the oscillation which leads to the blackout. Further, there is limited information about the energy flow through the grid in case of your traditional operation center. However, in case of your smart grid provides information and control on the transmission system. It makes the energy grid more reliable and it minimizes the possibility of widespread blackouts. Now the next component is distribution intelligence. So distribution intelligence means the energy distribution system equipped with smart IoT devices. So along with the smart meters, distribution intelligence can also identify the source of power outage. It ensures power flow automatically by combining automated switches. It optimizes the balance between the real and reactive power. Now what is reactive power? So in case of reactive powers, devices can store and release energy. It also causes increased electrical currents without consuming real power. Intelligent distribution systems, they maintain the proper level of reactive power in the system and also protects and control the feeder lines. Now plug-in vehicles. So smart grids have the infrastructure needed to enable the efficient use of plug-in electrical vehicles. Using plug-in electrical vehicle, we can reduce the dependency on oil, and further there is no pollution when vehicles will run on electricity. Plug-in vehicles rely on power plants to change their batteries. The energy service providers encourages the customer to charge batteries of plug-in vehicles in off-peak hours. Plug-in vehicles also can be used as an energy source in on-peak hours. So whenever there is more demand of energy, the consumer, the end customers can also get energy from your public plug-in electrical vehicles. Plug-in electrical vehicles get incentives from energy service providers for providing energy to the grid through discharging. So whenever end customers or the energy service provider get energy from your plug-in electric vehicle, then your plug-in electrical vehicle will get incentives and their battery will get discharged. Obviously, because we are taking electricity from them, so it will result in discharging of your plug-in electrical vehicles. Now smart grid communication. So there are various components involved which are responsible for the communication of your smart grid. These are your smart home appliances, the appliances which we use in smart homes, smart meters, gateways, data aggregator units, meter data management system. So basically the appliances will calculate the amount, will get to know that how much power you have used. Smart meters will show the amount of power that is used in your smart homes. Further, the communication will take place with the help of your gateways. Whole the data related to the power consumption is get aggregated at your data aggregator units, and meter data management systems are responsible for managing the power consumption at different appliances which are used in your smart homes. Now different networks that are associated with smart grid communications. Home area networks are used, neighborhood area networks are used, wide area networks are used, IP networks are used, and then sensor and actuator networks are used in the communication of your smart grids. Now for smart home appliances, the available protocols are followed. So for making the communication possible, these are the various protocols that are used. So first one is your C-bus. So the data rate which is offered by C-bus is 3500 bits per second, and it is able to handle cable length up to 100 meters. Next one is your DECT. The data rate is 64,000 bits per second. It operates between the range of 1880 to 1930 megahertz. Then an ocean, its data rate is 9600 bits per second, and it operates on 902 megahertz in North America. So this bandwidth is for North America. Next one is universal power line bus. So the data rate of universal power line bus is 480 bits per second, and it enables two-way communication. So your universal power line bus is your two-way communication protocol. So both your sender and receiver can communicate with each other at the same time using your universal power line bus. Next one is your thread. So the data rate for thread is lies between, the range is 20 to 250 kilobits per second, and IP addressing based 6-LoWPAN networking protocol is used in thread. Then Zigbee, the data rate is 20 to 250 kilobits per second. It operates on the bandwidth of 2.4 gigahertz band, and it follows IEEE 802.15.4 protocol. These things we have already discussed when we were discussing about the topic Zigbee. And the communication range of Zigbee is your 100 meters. Next protocol is your simplified cable solution. So the data rate which is provided by simplified cable solution is 9.6 kilobits per second. It works on twisted pair, and it is developed by Open Web Net. Now what are your smart meters and gateways? As we have discussed that one of the components which is responsible for making the smart grid communication possible is your smart meter, and another one is your gateway. So what is the role of these gateways and smart meters? So each gateway which are present in your network is responsible for connecting the various smart meters which are close to them. The gateways communicate mostly based on Wi-Fi, that is your IEEE 802.11. This is the standard which is used by Wi-Fi, and gateways also helps in two-way communication between various smart meters. Now smart meters forward the energy consumption information from the home appliances to the gateways. It also forwards the billing amount and the control information from the gateways to the home appliances. So basically smart meters act as intermediary between your gateways and your home appliances. So gateway act as link between smart meters and data aggregator units. Firstly there are home appliances, after that there will be smart meter, after that there will be gateway, and after that there is data aggregator unit. So this is a sequence. So your home appliances will interact with your smart meter will interact with gateways will interact with your data aggregator unit. Now data aggregator units aggregate the energy consumption or energy request of certain geographical area. They forwards the energy consumption information to the centralized coordinator, that is your meter data management system, and also maintains a buffer to queue the energy consumption information to the consumers. Now your data aggregator unit is communicating with your gateway as well as your meter data management system. So your meter data management system acts as a centralized coordinator for smart grid communication. It is handled by various energy service provider, and it is a part of operation center. It decides the price per unit energy to be paid by the consumers. Now smart grid security. Smart grid is a cyber physical system. Following are the vulnerabilities that are present in your smart grids. First of all, first is your integrity. So there is a need of integrity. That is your what is integrity? First of all, integrity is the credibility of the data collected and transferred over the grid. So the data which we are collecting with the help of your smart appliances that are used in your homes, so that data should not be changed, that data should be credible. Next one is your availability. So every component of your smart grid should be accessible for the transmission and collection of data. Dynamic system attacks. So based on the previous information, same type of request can be replicated by the attackers. Physical threat. So physical attacks to the smart grid components is possible. Coordinated attacks, that is the cascading failure of system in the smart grids, are also possible. So what are the possible attacks is that attacker can change the data or corrupt the data. It can affect the integrity of the data. It can the attackers can also attack the various components which are necessary for the communication of your smart grid. So they can also affect the availability of your smart grid. Next one is dynamic system attacks are possible, then physical threats are possible, and coordinated attacks are possible. Now smart grid and cloud application. So your smart grids can be integrated with cloud computing, which results in energy management, information management, and security. The energy management in smart grid can be more efficient by using cloud applications, because cloud computing provide various services that can be used for providing energy management in your smart grids. Integrating cloud computing application for microgrid management in the form of different modules such as infrastructure, power management, and service. Information processing in smart grid fit well with the cloud computing and storage mechanism available for the cloud application. Information from different components and supply and demand state condition can be shared with the help of your cloud computing. Now the next topic is industrial IoT. So what is industrial IoT? Industrial Internet of Things is an application of IoT in industries. So basically you are using IoT in your industries, which make industrial IoT. So industrial IoT is an integration of your Internet of Things plus Industry 4.0. So why we are integrating these IoT and Industry 4.2 and making industrial IoT? So we are doing this to modify the various existing industrial systems and making these existing system more automated. So IoT, so Industrial Internet of Things links the automation system with enterprise planning and product lifecycle. So here in this diagram you can see that we are so the intersection of your Industry 4.0 and Internet of Things is your industrial IoT. Now what is Industry 4.0? So the automation and data exchange in manufacturing technology is involved in your Industry 4.0. These are the cyber physical system with the Internet of Things and cloud computing. Industry 4.0 is also called as your smart factory. Now IIoT includes machine learning, big data technology, machine to machine interaction, and automation. IIoT is supported by huge amount of data collection from the sensors that are deployed in your industries. It is based on wrap and reuse approach rather than rip and replace approach. Now here this is the same diagram showing this is the integration between your IIoT and your consumer IoT. So next we will discuss the various difference between your industrial IoT and IoT in the further slides. So now what is IIoT? As I have discussed that IIoT is the integration of your Internet of Things and Industry 4.0. Now in case of your Internet of Things, various physical objects are involved, various sensors are involved. So integration of your physical objects, Industry 4.0 and cloud, it makes your IIoT. So what are the various components? IIoT is a network of physical objects, system, platforms, and applications. Now the requirements of IIoT. So in case of your IIoT, big data analytics is required, hardware and software connectivity is required, cloud platform is required, and application development is required. Now in case of your IIoT, There should be a need of end-to-end security. The user experience should be great. The transition to smart machines, there should be transition to smart machine, asset management should be there, big data analytics should be there, cloud for efficiency and agility should be there, and access for each and every component, that is anything, anytime and anywhere, should be present. Now, design requirement. So, to use an IoT device for industrial application, the following design objectives are to be considered. The first one is energy. So, the time for which the IoT device can operate with limited power supply. And second one is latency. So, in industries, we need to take decisions in real time. So latency defines the time required to transmit the data. So this latency should be low, and transmission of data should be in real time. Next one is throughput. So what is throughput? Throughput is the maximum data transmitted across the network. Next objective is scalability. So in IIoT, the number of devices that can be handled should be scalable. It means we can either increase the devices and decrease the devices on the requirement of demand. Next one is topology. So the communication among the devices, that is your interoperability, should be there, and safety and security should be there to support secure communication between different devices. Now here is the difference between your conventional IoT, that is your Internet of Things, and industrial IoT. So your IoT focus on convenience of individuals. However, IIoT focused on efficiency, safety and security of the operation. So basically IIoT is related to the operations that are taking place. However, IoT is associated with the individual. So IoT is responsible for improving the quality of service of the end user. However, your IIoT is responsible for making the operations more efficient. In IoT, machine to machine communication is limited. However, in case of your IIoT, machine to machine communication is extensive. Application areas are at consumer level in case of your IoT. However, in case of your IIoT, applications areas are at the industries. So as the name suggests, it is only for industries, so applications areas are at industry. Now this diagram is showing that how your machine to machine is which components your machine to machine is focusing, and which components your IoT is focusing. Now service management in your IIoT. So service management refers to the implementation and management of the quality of services which meets the end user demand. Service is a collection of data and associated behavior to accomplish a particular function or a feature of device or a portion of device. So services can be of two types. First one is your primary service and second one is your secondary service. So primary service are the basic services which are responsible for the primary node functions are termed as your primary services, and the auxiliary functions which provide services to the primary service and secondary service are termed as your secondary services. Now the applications of your industrial IoT. So your industrial IoT are applicable in your manufacturing industries, healthcare industry, transportation and logistic industries, mining industries, firefighting. All those are the application areas of your IIoT. Now the challenges of IoT. So worker health and safety is the utmost requirement in case of your IIoT, and achieving this is the biggest challenge. Then regulatory compliance, environmental protection is a challenge, optimized operations are the challenge. Now what are the various challenges that are faced by your workers in your industrial IoT? So handling and storing or using hazardous substances, oxygen deficiency is there, particulates are present, radiation, psychological stress. Now, risk associated with IIoT in manufacturing. Though IIoT provide new opportunities, but few factors may cause hindrance in the path to success, which are lack of vision and leadership, lack of understanding of values among management employees, costly sensors, and inadequate infrastructure. Now, how to meet these challenges? So, manufacturers should use software capabilities to improve operational efficiency through predictive maintenance. So, predictive maintenance should be done in case of your IIoT. Saving on scheduled repair, reduce maintenance cost, reduce number of breakdowns. So for example, in case of your IIoT, if you are using proper analytics, then this will result in the production of goods which are not faulty, because this analytics that is performed on the data helps in predicting the faults that are possible, and further helps in managing those faults. Further, analytics also helps in predicting the future faults that can occur in a machine. For example, you can use various kinds of sensors on machines, and based on the data of those sensors, you can predict whether this machine is going to be faulty in the future or not. For example, on a motor, you are using vibration sensor, heat sensor, right? So on the values of those two sensors, that is heat and vibration, you can predict whether that motor is going to be faulty in the future or not, right? If the temperature value is getting high, if your motor is getting heated up, and if the vibration which is produced by the motor is not appropriate, then on the basis of these condition, you can predict that whether this motor is going to get faulty in future or not, and on those prediction you are going to prevent any kind of accident that can happen in industries, and any kind of hazard that are possible. Now, benefits and research trends of IIoT. Recent research, so these are the benefits. So there is improved connectivity among the devices, there is improved efficiency, upgraded scalability, it reduces the operation time also, remote diagnosis is possible, and it is also cost effective. Now the challenges, recent research challenges in IIoT are, first one is to improve the communication among the different things or the objects. Second one is to develop energy efficient techniques so as to reduce power consumption by the sensors. Third one is to develop context aware IoT middleware for better understanding of sensor data. Next one is to create smart object with large memory, processing and reasoning capabilities. Now, data handling and analytics. So far I was talking about we can do analytics over the data which we are getting through sensors, which we are getting through IoT devices or IIoT devices. Now we will discuss that what exactly is this analytics and what exactly is data handling, how we are going to do this. So data handling ensure that the research data is stored, archived and disposed of in a safe, secure manner during and after the conclusion of a research project. It includes the development of policies, procedures to manage data handled electronically as well as through non-electronic means. In recent days, most data concern is big data, as the data which is produced by your IoT devices is massive. Due to heavy traffic of data which is generated by your IoT devices, it becomes difficult to handle this amount of data. Huge amount of data that is generated by your deployed sensor is difficult to manage as well as to store in a safe manner. Now, what is a big data? So big data technology describes a new generation of technologies and architectures designed to economically extract value from very large volume of wide variety of data by enabling high velocity capture, discovery and analysis. Big data shall mean the data of which the data volume, acquisition speed or the data representation limits the capacity of using traditional relational method to conduct effective analysis of the data, which may be effectively processed with important horizontal zoom technology. So these are the definition which is provided by your NIST, that is your National Institute of Standard and Technologies. So basically big data is a massive amount of data which is generated and which is difficult by your traditional or conventional relational method to manage. Now types of data. So your data can be structured and unstructured. So first one is your structured data. So the data that can be easily organized is your structured data. It is usually stored in relational databases. Structure query languages can be used to manage structured data in databases. It accounts only for 20% of the total available data in the today's world. So basically the data which is easy to manage and easy to organize is your structured data, and it is only just 20% of the total data. So the next 80% of the data is your unstructured data. So the information that do not possess any kind of predefined model is your unstructured data. Traditional RDBMS are unable to process unstructured data. It enhances the ability to provide better insight to the huge data set. It accounts for 80% of the total data available in the today's world. Now the characteristics of big data. So big data is characterized by your 7 V's. So basically the volume is high, the velocity is high, the variety of data, the data is heterogeneous, variability, veracity, visualization and values. Now data handling technologies. So first one is your cloud computing. So cloud computing is responsible for handling your big data, as it provide on-demand self-service, broad network access. It will provide resource pooling, rapid elasticity, measured services. These all features we have discussed when we discussed your cloud computing in the previous lectures. Now the service models provided by cloud computing for handling your data is infrastructure as a service, platform as a service and software as a service. Now second technology is your Internet of Things. So according to Techopedia, IoT describes a future where everyday physical objects will be connected to internet and will be able to identify themselves to the other devices. So sensor embedded into various devices and machines and deployed into fields. Sensor transmits the sense data to the remote server by internet. Continuous data acquisition from mobile equipment, transportation facility, public facility and home appliances. Now data handling at your data centers. So storing, managing and organizing data is required. It estimates and provides necessary processing capacity. It provides sufficient network infrastructure. It effectively manages energy consumption, replicates the data to keep backup, develop business oriented strategies, solution to big data. It helps business personnel to analyze existing data, and it also discovers problem in business operations. So data handling is responsible for achieving all those features. Now this is the life cycle of big data. So first phase is your generation. So where your big data is generated, it can be your enterprise, IoT, biomedical data and other data. Now once the data is generated, we need to acquire that data. So next phase is acquisition. So data collection, data transportation and data pre-processing. These three phases are involved in your data acquisition phase. Next one is storage. So once the data is acquired, we need to store that data. So various technologies can be used in order to store the data. They can be Hadoop, Mapreduce, NoSQL databases. And after that, in order to make decisions, we need to analyze the data. So the various technologies that can be used are Bloom filter, parallel computing, hashing, and indexing. Now the data source. As I have discussed that the first phase of your big data is your data source, where the data is generated. So it can be your enterprise data, so online trading and analysis data, production and inventory data, sales and other financial data. Further, the IoT data from industries, agriculture, traffic, transportation, medical care data from public department and families, the data generated by gene sequencing in case of your biomedical data, then data from your medical clinic and medical R&Ds, and other fields such as your computation, biology, astronomy, nuclear research. All these fields are responsible for the generation of your big data. Now data acquisition. So I have already discussed the three phases of your data acquisition, that is your data collection, data transmission, and data pre-processing, right? So in case of your data collection, log files and records, the file that are automatically generated by data sources to record activities for further analysis. Sensory data such as sound wave, voice, vibration, automobile, chemical current, weather, pressure, temperature. Complex and variety of data collection through mobile devices. Now we need to transmit this data, so we can use various transmission protocols in order to transmit the data, and it can be categorized as your inter-DCN transmission and intra-DCN transmission. And further, some pre-processing is required on the data, since the data can be inaccurate, incomplete, unreasonable to fetch some information from that data. So we need to perform some pre-processing in order to get the information from that particular collected data. Now data storage. So basically two types of systems are used in order to store your data. First one is your file system and other one is your databases. So file system, distributed file system that store massive data and ensure consistency, availability and fault tolerance of data. Next is GFS is a notable example of distributed file system. So this is an example of your distributed file system. Hadoop is also one example of your distributed file system. Now databases. So emergence of your non-traditional relational databases, that is your NoSQL, in order to deal with the characteristics that big data possess. So NoSQL can be used in order to store your big data. Three main non-SQL databases are key value databases, column oriented databases and document oriented databases. Now Hadoop. So Hadoop is a software framework for distributed processing of large dataset across a large cluster of computers. It is an open source implementation for Google GFS and Mapreduce. Apache Hadoop, Mapreduce and Hadoop distributed file system component originally derived respectively from Google Mapreduce and Google File System. Now building blocks of Hadoop. A module containing the utilities that support the other Hadoop components should be there. Hadoop distributed file system should be there. It should provide reliable data storage and access across the nodes. Next one is your Mapreduce. So Mapreduce is the next component, which is a framework for application that process large amount of data set in parallel. Yet another resource negotiator is in your Mapreduce, and next generation Mapreduce, which assigns CPU memory and storage to application running on Hadoop cluster. Now there are two types of nodes which are available in your Hadoop distributed file system. First one is your centralized node and another one is your distributed node. Apart from these two nodes, name node and data nodes can also be present. So the centralized node are so basically these centralized nodes are your name nodes which maintain metadata info about the files, whereas your distributed nodes are the data nodes which stores the actual data. Files are divided into blocks and each block is replicated. So name node store file system metadata, maintain two in main memory tables to map the data nodes to the blocks and vice versa. Data nodes store actual data. Nodes can talk to each other to rebalance and replicates the data. Data node update the name node with the block information periodically. Before updating data nodes, it verifies the checksums. So checksum technology is used in data nodes for verification. Now jobs and task trackers. So first one is your job tracker. It runs on your name node. It receives the user's jobs, decide how many tasks will run, and further it decides where to run each mapper. Now the task tracker. It runs on each data node. It receives the task from job tracker and always in communication with your job tracker reporting progress. So basically there are two types of node. One is your centralized node, that is your name node, and other one is your data node. So data node, so centralized node only maintains the metadata of the particular set of data, and further that is linked to the actual data which is stored in your data nodes. Now this is the master slave architecture of your Hadoop. As I have told that there are two types of nodes, that is your name node and data node. So your name node is in your HDFS layer which stores the metadata, and further this name node is connected to your data node which stores the actual data. So actually the data is present here and name node only store the metadata. So metadata is the data which stores the attribute of particular data. Now the questions. So first question is, which of the following is true about traditional electric grids? Options are: monitoring and restoration is done automatically. Energy is distributed from plant to homes or industries. Energy generation is done in distributed power plants, and there is bidirectional communication. Anyone? So in case of your traditional electrical grid, the energy is distributed from plant to home or industries. There is no automatic monitoring and restoration. Energy is not distributed over various power plants, and there is no bidirectional communication. Now second question is, power monitoring along with asset management and optimal utilization fall under which categories of smart grid? Options are: power system efficiency, the second one is real-time pricing, third one is distributed generation, fourth one is power quality. Anyone? Correct option is power system efficiency. Next question is, which of the following statements are true about net metering? Statements are: installation of smart meters does not contribute to your net metering. Second statement is, consumer are speed high on supply in excess amount of generated energy to do the grid during on-peak hours. In case of off-peak hours, the price is less. So you have to tell that which of the following statements are true. The options are either statement 1 or 2, statement 1 and 3, 2 and 3, 1, 2 and 3. All the three statements are correct. Anyone please? No? Okay. So the statement second and statement third is correct. However, statement 1 is not correct. So your installation of smart meters contribute to your net metering. Now question number 4. Which of the following is true about plug-in electric vehicle? Options are: plug-in electric vehicle does not rely on power plant to charge their battery. And the consumer is discouraged by energy service provider to charge their batteries of PEVs during off-peak hours. By using electric vehicles does not reduce pollution. PEV can be utilized as an energy source during on-peak hours. So which of the following is true? So your PEV can be utilized as energy source during your on-peak hours. What are the advantages of traditional operation centers? Options are: it tries to confirm that the amount of energy generated is utilized. Option B is grid voltage drop due to excessive current generation lead to unsteady grid. Controlling capabilities are not boundless. Fourth one is none of these. So which of the following is an advantage of your traditional operation center? Anyone? So correct option is none of these. Now question number 6. Avoiding unwanted current flow through grid is tackled by. Options are: demand side energy distribution by the grid, self-healing capability of the grid, energy servicing in specific geographical location in smart grid, and all of these. Anyone? Correct option is all of these. Now select the correct order for the evolution of your industry 4.0. So you have to tell that how your industry 4.0 is evolved. So option A is power generation and mechanical automation is done, then smart automation is done, then electronic automation is done, and then industrialization. According to option B, power generation and mechanical automation is done. After that, electronic automation is done, then industrialization, and then smart automation. Then third option, according to third option, first of all industrialization is done, then power generation is done, then mechanical automation, then electronic automation, and then smart automation. Then option D is power generation and mechanical automation, industrialization, electronic automation, and smart automation. So which is the correct order for the evolution of your industry 4.0? Correct option is option D. First of all, power generation and mechanical automation is done, then industrialization, then electronic automation, and after that smart automation. Now question number 8. Industrial Internet of Things is a network of physical objects, systems, platforms, and applications. These networks can interact with each other, external environment, but not with other people. State whether this statement is true or false. Anyone, please? Okay, so this statement is false. So your industrial internet of things, in case of your industrial internet of things, the interaction can take place with peoples also. Now next question is, which of the following design objectives are considered while using IoT devices for industrial application? Options are latency, throughput, scalability, all of these. Anyone? Correct option for this is someone replied D. Right. Can you please speak out because it will be difficult for me to read your chats here. So correct option for this is D. Now question number 10. The intelligent transport system is least likely to render which of the following connectivity? Vehicle to vehicle connectivity, vehicle to sensor connectivity, vehicle to road infrastructure connectivity, and vehicle to home connectivity. Anyone please?
Is it D, ma'am?
What? Speak louder.
D.
D.
Last
Right.
option.
Right. D option is correct. Now question number 11. Intelligent radio modem, that is your IRM, can be connected to an IP serial device but not to a non-IP serial device to extend the capabilities necessary for monitoring and communicating with other technologies. So is this statement true or false? Anyone? So this statement is false. Now question number 12. Wi-Fi, RFID and other wireless technologies are utilized for preventing mining accidents.
True, ma'am.
Yes, it is true. Now next is fill in the blank type of question. Approximately around blank % of the total data available currently in the world is unstructured. Options are 20%, 40%, 60% and 80%.
80%.
Right, 80%. 20% is structured and 80% is unstructured. Now question number 14. In flow of data after data generation and acquisition comes the storage of data. State whether this is true or false. So basically according to this statement, first phase is generation, then acquisition and then storage. Is this true sequence or not?
True.
Right, true. Because sequence is generation, acquisition, storage and then analysis. Now match the following type. So statement 1 is uploading 70 hours video to YouTube every minute. Whether this is visualization, volume, variety and velocity you have to tell. On average 130 millions of tweets per day. Presentation of data in graphical format, most of the data being unstructured or semi-structured. So you have to tell that these statements are related to which of these statements?
C.
C. So first one is related to B. You are telling that uploading 70 hours of video to YouTube every minute is your is your volume. Then second, on average 130 millions of this is then velocity. Then after that 3 to A. The presentation of data is visualization, correct. Most of the data being unstructured and structured. This is your variety, right. This is your C. Okay. Okay, then only 1 week is left. That we will meet on next Tuesday and discuss the question of week 12 on Tuesday. Okay, thank you.